Here's problem 10-12. Four identical particles, mass of each 0.4 kilograms, are placed at the vertices of a rectangle 2.5 meters by 4 meters and held in those positions by four light rods which form the sides of the rectangle. Was the moment of inertia of this rigid body about an axis that passes through the midpoints of the shorter sides and is parallel to the longer sides? Alright, let's imagine what we have here. We got four identical masses at the ends of a rectangle. One side is 4 meters long, and the other side is 2.5 meters long. And then we're going to have an axis that goes through the midpoint of the shorter side. So this will be our axis, this red line here. And this thing will tend to rotate then around that axis, something like this. And we want to find the moment of inertia of this configuration about that axis, noting that the rectangle is held together by four light rods. Now, if we use the word light, we're going to take that to the extreme and say that the rods themselves have no mass. So the word light means massless. And so we don't have to worry about the rods that are connecting these four masses. We just have to worry about the masses themselves. Each mass being 0.4 kilograms. So we have the same mass at each corner of this. Alright, if we set up our moment of inertia for point masses, that's a summation of every mass multiplied by its distance from the axis of rotation squared. Now in this case, each of our masses is actually going to be located the same distance away from the axis of rotation, which is going to be 1.25 meters, because they're going to be located from that radius from the axis. So our r is going to be 1.25 meters. As we write this expression out, this would be mass 1, r1 squared, plus mass 2, r2 squared, plus mass 3, r3 squared, plus mass 4, r4 squared. All of our masses are the same, so this is really 4 times m times r squared, where our r's are the same as well. This is going to be 4 times 0.4 times 1.25 meters squared. And what does that give us? 2.5 kilogram meters squared. So there's our moment of inertia of this object about this axis, 2.5 kilogram meters squared.